right, this is question 3 from the fall 2019 final. We're given a function 2x squared, and it's a two-part question. First, we're supposed to find the derivative. I didn't write out all of the directions. It's not as easy as it looks. We've got to actually find that using the limit definition of the derivative. And then once we've done that, we're going to find an equation for the tangent line when x is -3. Okay. So I like to have a picture whenever I'm using the limit definition of the derivative. So this is just going to be a parabola. It's a little steeper than the usual one, although I'm not super concerned about drawing it exactly to scale. It really is just a place for me to put my points. I'm going to say if I got a point here, x, the y value would be 2x squared. If I have a nearby point, I would call that x plus h. Now, right now, here's x, and here's x plus h. Okay. H, remember, represents the signed distance between the two x values. So h is allowed to be negative, in which case x plus h is just to the left of x. Okay. All right, and then this would become 2 times x plus h, the quantity, squared. Okay. So I want to remember, when I'm plugging in x plus h, just like there are parentheses around the x here, I can put parentheses around the x in the formula for f. That's just a placeholder for my input. I'm going to fill in those parentheses with whatever I'm plugging into f, which in this case is x plus h. And then if I draw in the secant line, I know that f prime of x is going to be the limit as h goes to 0. So as the signed distance between these points goes to 0, so they're getting closer and closer together, of just the slope of this secant line. And that's going to be the rise over the run. Okay. I'm going to make sure that I subtract this point minus this point. That way the run is just x plus h minus x. It's just h. I could subtract the other way, but then my run would be negative h. And it's very easy to forget that negative sign. Okay. So on top I've got 2 times x plus h squared minus 2x squared. Now, anytime you set up the limit of a slope of a secant line, you should have an indeterminate form. Pretty obviously, the bottom's going to 0. The top is going to 0 as well. So I need to do some simplification to try to cancel this. Okay. And of course, in this case, really don't want to be using L'Hopital's rule because we're trying to use this to find the derivative of 2x squared. So for this problem, I don't know the derivative of 2x squared, and therefore L'Hopital's rule is off limits. Ha ha ha, pun. Okay, so this is going to be the limit as h goes to 0 of 2. Remember that x plus h squared just means x plus h times x plus h, and I'm going to have to FOIL that out, minus 2x squared all over h. So that's going to be the limit as h goes to 0 of 2 times x squared plus 2xh plus h squared minus 2x squared all over h. I'll distribute this 2, so that's the limit as h goes to 0 of 2x squared plus 4xh plus 2h squared minus 2x squared all over h. The 2x squared and the minus 2x squared cancel, and now every term on top has at least one h in it. So I can factor out an h on the top, and then it's multiplied by 4x plus 2h over h. Now I can cancel those h's, and we're getting the limit as h goes to 0 of 4x plus 2h. But now I can plug in 0 for h, and so I'm just going to get 4x. Now, of course, at this point, we know the power rule, and so I can double check. I was supposed to get, for my formula for f prime, 4x. Okay. So there's our answer to part A, although be aware, if you just give me that answer, you have not done what the problem asked you to do, which was find it from the limit definition. All right, part B, we're supposed to find the tangent line when x is equal to -3. So if I'm finding a tangent line, I always need two things. I need a point, and I need the slope. So for my point, well, I was given the x value. It was -3. To find the y value, I'm just going to plug into f. So that's going to give me negative 3. Negative 3 squared would be 9, times 2 would be 18. The slope is just going to be f prime evaluated at negative 3. So since I found a formula for f prime, I can just plug into that. That's 4 times negative 3. That's going to be negative 12. And then since I have a point and the slope, I like to just use point-slope form. Rise is equal to slope times run, where I'm calculating the rise and the run using this point and an arbitrary point xy. So that this point, where I've actually evaluated f of negative 3, and an arbitrary point xy. So my rise would be y minus 18, my slope we said was negative 12, and my run is x minus a negative 3, which becomes x plus 3. Totally fine to stop with it in point-slope form. If you want to simplify it to solve for y, you certainly could. Y minus 18 is negative 12x minus 36. And so that would mean that y is equal to negative 12x minus 18. Either form for the tangent line would be totally fine.